Geometric sequences are somewhat less common than arithmetic sequences on the ACT, but they're really easy points to get, and it's all about marking off in bite-sized pieces. So this is the question you will most likely see. There are a couple variations on this. You'll see them in the book. But here's what you do. Relatively straightforward. You find what changes and the way in which it changes to predict the next term. These questions are almost always about the next term or the term after that. You sometimes have to go 2 terms. Let's talk a little bit about what a geometric sequence is before we get started. So a geometric sequence, unlike our nice, linear, friendly arithmetic sequence, is a curve. It has, instead of a common difference, a common ratio. By the way, one of the variations that's very rare on this is find the common ratio. So what does that mean? Well, difference is subtraction, ratio is multiplied. So an arithmetic sequence looks like this: 2, 4, 6, 8. Each time I add 2. Or if I subtract consecutive terms, 4 minus 2 is 2, 6 minus 4 is 2, 8 minus 6 is 2. Old hand for you people that just watched the arithmetic sequence video or whatever the material. In contrast, geometric sequences multiply. They're, in a sense, exponential, although not always. And they form curves. Why curves? Well, lines have a rate of change that never changes. The rate of change is constant. Curves, they don't. So the common difference here is 2, but then here it's 4, then here it's 8. I'm multiplying each previous term by 2. So they can go up and get really big. They can go down. They can go like this. Sorry, I had to lift my arm up over the question so I could do this weird thing. All right, that's the big deal, common ratio. So whenever you're looking at these to find the next term or the term after that or whatever, just start eyeballing things. Start wherever you want. Now, some people say, well, start with the number. I say start with the numbers first because I think that's easy. But, you know, you will hear people say, well, start at the back because you'll be able to mark off more questions or more answer choices. Sometimes that's true. But, you know, at the same time, the ACT kind of knows people do that, so they jigger it. So that I don't think in the long run it'll matter. And I think it takes a little extra thinking to do that. So because we read left to right, I typically go left to right. But it's up to you. I go from 24 to 12 to 6. Okay, fairly obvious. 24 to 12, that's 12 is half 24. 6 is half of 12. So my next term will be half of 6, 3. So now, just like in equivalence questions, I'm going to mark off everything that doesn't have a 3 coefficient. So let's put my letters up here. I've got A, B, C, D, and E. Making sure I didn't run out of room. So A's gone. C is gone. All right, that's 2 off the bat. Right off the bat. Now let's look at A's. And when we talk about variables, it's all going to be about exponents. I go from A to the power of 8, A to the power of 6, A to the power of 4. So I lose a square, A squared every time. Lose A squared every time. I go down 2 every time. So my next one needs to be A squared. Let's see what I can get rid of. A and C are already gone. B is gone. D and E are still there. All right, I'm already down to a 50-50. Not bad. All right, let's look at B. I go from 5 to 4 to 3. So B needs to be squared. I'm left with D and E. D and E both have B squared. Now here's the hard part, C. If you're not too good at your exponents, you're not too comfortable with your exponents, please take a look at that because that's a really important skill and that's what's about to show up. C squared. To C, I lose a C, right? I lose 1 power. Now C's gone. But C's not really gone at all. We went from C to the first power. We lose a power every time with C. C to the 0 power, right? not an equal sign, an arrow. And anything to the 0 power, anything at all to the 0 power is 1. So that c isn't gone. That's just a 1. So I can even write it up here if I want. C to the 0. Well, what's c going to be now? I forgot to put my b up here. Well, c, 0 minus 1 would be negative. And here's the trick. You can't leave things with negative exponents. How do you get rid of a negative exponent? Move it to the denominator of a fraction. Make it a fraction, essentially. C to the negative first. Well, we're going to move all this. 3a squared, b squared over c. That means letter E is correct. Mark off bite-sized pieces. These aren't too bad. Just get a feel for them, practice them a little bit. It's a good point to get because it's not too complicated.